Greetings, welcome to Lab 5, Part 4 on hypothesis testing. So we're going to do problem 4.30 in this one on car insurance. Let's go ahead and get over here to our script file too right away. So 4.30, car insurance Part 1. Car insurance company advertises that customers switching to their insurance save on average $432 on their yearly premium. A market researcher at a competing insurance discounter is interested in showing that this value is an overestimate, so he can provide evidence to the government regulators that the company is falsely advertising their prices. He randomly selects 82 customers who recently switched to this insurance and finds an average savings of $395 with a standard deviation of $102. Are the conditions for inference satisfied? In other words, we're going to do a hypothesis test here. We're going to go and see whether or not we have evidence, convincing evidence to take to the government regulators to say that this lizard company is overstating how much money you're actually going to save if you switch to them for insurance. Okay? So what are the conditions for inference that we need to verify? Well, first one that we need to infer is independence. So independence is met, we're assuming here on two bases, since the sample size is less than 10% of the population. In other words, we're not taking so many out of the population that we're actually going to start changing the probability of successfully or of it being actually random, okay? And the sample is random. Our intrepid competitive insurance guy took a random sample here, okay? All right, now the condition normality, that one, modality is harder to judge. In other words, is it roughly symmetric? Is it bell-shaped? But the sample size is large. It is larger, much larger than 30. So we are safe here. Okay? All right, so we're looking pretty good. All right, now they just kind of took off your training wheels and threw you into the deep end of the pool and said, perform a hypothesis test and state your conclusion. So in other words, they're expecting you to now understand what that means. Now there are lots of pieces to that. We talked about that in the previous problem where we did a hypothesis test. We need to make sure that we go through those 5 steps or so that were stated in the textbook and that we showed in the previous slide with a bit of addendum. Main thing is that we're going to state our decision rule. Okay, so let's go ahead and get going on that. So first thing is, always, is we want to state the null and the alternate hypotheses. That's just beginning always. So state the null and alternate. And we're going to do those both in words and in symbols. So our null hypotheses is going to be given by what? Well, let's see in words. The savings, the average savings, excuse me. The average savings is as stated. That means it is what? It is what? 400, let's scroll up just a smidge here so we can see there, $432. All right, so what's our intrepid competitor think here? Well, he thinks that they're full of malarkey, and he's saying that, oh, no, it's less than that they're overstating their case. The average savings is less than $432. Okay, so that's how they're stating the null and the alternates in English. How we're stating, excuse me, the null and alternate in English. How would we state those symbolically? And part of what we're doing here, and the reason we're taking the time to really think about this as we're typing this up, is that it's very important that you know what parameter that you're talking about. we've been pretty much working exclusively with means, but as we'll see as we get further into the course, we're also going to talk about proportions and other parameters that we're estimating. And so the parameter of interest, if you can make sure you get what that is up here in the in English version, when we said average, then that'll really help you when you come down here to do it symbolically, and it'll help you pick the appropriate test. So the alternate is what? Is that, excuse me, not the alternate, the null. The null is that mu is equal to $432. And then the alternate hypothesis is that the mean is what? The mean is less than $432. In other words, they're not saving as much as they stated, okay? All right, now just a quick aside here. What if I wanted to put a dollar sign in here? Whee, that's kind of tough. See, I was able to do it up there in words, but if I put a dollar sign down here, it's going to shut off my my tech. So the way you do that is you put a / and a dollar sign together, and that'll give you the dollar sign, okay? But I'll tell you what, let's just leave it off and make our life easy. Just don't worry about it, because when you state the null and alternate symbolically, the units typically aren't included anyway. Okay, so that's part one, state the null and the alternate. Next part is we need to state our decision rule. In other words, we need to say what is it that we're going to use to reject the null hypotheses. So our decision rule is we're going to say reject. Notice they didn't give us a level of significance here, so we're going to set it ourselves. So we're going to reject the null if the p-value is less than 5%. In other words, set alpha equal to 0.05. Okay, now they talk about that in the book. This is kind of the gold standard. It's, if you don't know, if they don't tell you any different, then it's a safe assumption that alpha was set to 5%. Bit of history about that. If you want to read some interesting stuff about that, read a book called The Lady Tasting Tea, and you can learn a little bit about this great character in statistics, Ronald Fisher, and who he's more or less the god who told us all to set it to 5%. Okay, so once we've done that, we need to go calculate the test statistic and the p-value. So let's go calculate the test statistic. So go calculate our test stat, which in this case, that's going to be the z, okay? So we need to go calculate z. I'm again going to do that by inserting a chunk. I'll let R take care of the arithmetic duties for me. So how do we calculate our z here? Well, that's going to be x bar minus mu divided by the standard error. So let's see, what did he come up with for his x bar? Well, he got for his x bar $395. So that's going to be $395 minus the mean. Now what mean are we going to use? Well, it's the mean of the null hypotheses, which is 432. And we're going to divide that by our standard error. Our standard error is going to be the sample standard deviation, which is 102, divided by SQRT for square root of the sample size, and the sample size was 82. Alrighty. We went over that again in the last time we did that. Make sure that you have the formula for calculating z stowed away nicely someplace in your reference book where it's easy to find. Okay, so let's go ahead and run that. And we get a, whoa, look at that. That is a huge z-score. We get a z of negative 3.284797, which means that the value of 395 was more than 3 standard deviations below the mean. So already the evidence is weighing handily in favor of the alternate hypotheses. In other words, we should say that it is significant evidence to reject the null hypothesis and assume that the alternate is the way of the world, is that they're not saving as much as what they actually said. Okay, so next thing that we want to calculate is the p-value. So how do we calculate the p-value? All right, so I'm going to go over to the whiteboard one more time and remind you about calculating the p-value. So in sort of chunk, and then we'll come back here as to actually what we do to do that. So let's get over to the whiteboard here. So let's get a rather nice drawing of what the null and the alternate, actually just the null, I don't need the alternate, what the null hypothesis says the way of the world is. So the null hypothesis states the following. It says that the mean here was $432. In other words, that the sampling distribution of x bar is going to be centered at that. Now what we came up with, the value that we calculated for, actually our researcher calculated, we didn't, they calculated that the savings was actually $395, but we calculated that that was -3 standard deviations below the mean. So this down here is going to be -395. And so the corresponding p-value, or the probability of seeing 395 or more extreme in the distribution of the null, is that little teeny area right there. So that's going to be our p-value right there. It's going to be a really small value. Now, notice also that we calculated a test statistic, z. And our test statistic, z, is basically a standardization of this particular distribution. In other words, we took this distribution and we standardized it by pumping it through z, and we ended up down here. And we know in the standard normal that the mean is at 0. And we saw that the value of the test statistic was -3.28 roughly, okay? So this area to the left of 3.28, that is also exactly the same thing as what we would have calculated up in the distribution of the null. In other words, these two numbers are going to be the same, all right? So it is up to you how you calculate it, but in either case, we're going to be using p-norm. If we use p-norm and we use the distribution of the null, then it's going to be from what? Well, from the left-hand side, it's going to be, whoops, that should not have been a negative there. Sorry about that. I was getting confused with my silly z-score and putting negatives on everything to the left. That should not have been a negative, okay? All right, so that is a positive. We would have had, what, $395 would have been the value we would have summed up to, with a mean of 432. And a standard deviation, or standard error, excuse me, of $102 divided by the square root of 82. You can see where that, nothing the matter with that. That's awesome, but that's a little more typing than I would like to do. So since I went through all the hassle of calculating the test statistic anyway, I typically will use the test statistic to calculate my p-value. Because notice that that's going to be a heck of a lot easier to type in, isn't it, right? But the thing to note is that these two are equal to each other. And I really strongly encourage you to type them both in and take a look and see that you get exactly the same thing both ways. All right, so let's go back to RStudio. So calculating our p-value here, we're going to put in p-norm, put in -3.28. comma 0, comma 1. By the way, if you leave the 0 and the 1 off, if you want to really be lazy, R will still do it, okay? It'll still interpret that for you. And we end up with a really small p-value. We end up with 0.00051, etc., okay? So we end up with a very small p-value here. Okay, so what we need to do now, the next step in our hypothesis test, is the decision rule, or make a decision, or conclusion. We'll go conclusion because I think that's what the textbook uses. So what is our conclusion? Our conclusion here is to reject the null hypotheses. The p-value is smaller than alpha. Okay. All right. So one last one. They say, do you agree with the market researcher that the amount of saving advertised is an overestimate? Explain your reasoning. So basically part C here takes the next step of the hypothesis test that's necessary, and that is take your conclusion or your decision and state it in English, okay? So I'm going to put it back up here both ways. I want to say decision also. Decision / conclusion, right? So what did you decide? You decided to reject the null hypotheses. But down here in part C, this is the important part is, all that work you did above, what the heck does it mean? Explain it to your mom. What happened here? And we would say we have evidence that the company is overstating the amount of savings. The amount of savings is significantly less than the stated value of 432. Exclamation point. Okay, calculate a 90% confidence interval for the average amount of insurance all customers switch. In other words, they want us to do a 90% confidence interval, and then they want us to do something about showing that it is congruent with our previous results. Okay, so how do we go about getting a 90% confidence interval? Okay, well, to do a 90% confidence interval on this, what we need to do, hang on a second, I'll get the right page in my notes here. Sorry about that. Oh yeah, there we go. Flip the page to the right page. There we go. So we need to get x bar plus or minus z star times the standard error of the x bars. So let's go ahead, insert a chunk, and let's let R do the arithmetic for us. So let's see. Our x bar was 395. And then we'll do the lower bound right away. So that's going to be minus our z star. Well, since we're using 90%, we're going to use 1.64 for our z star. And then that's going to be times our standard deviation of the estimate divided by the sample size, better known as the standard error, which is 102 divided by SQRT of 82. Okay, so that's going to be our lower bound, and then let's go ahead and just maybe copy this and paste it, and then we'll come down here and change that to a plus, and that's going to be the upper bound of our confidence interval, right? That's the plus or minus part. So let's go ahead and run each of those, and what do we get? So we get, whoops, my mistake. Oh, look what I forgot to do. Yes, I forgot that. I forgot to use juxtaposition. Oh my lord, oh, shame on me. Okay, so let's go ahead and run that, and so we get that the lower bound is $376.53, and then the upper bound is did I do them both there? Hang on a sec. I'm going to do it this way. Run current chunk. There we go. So we get 376.53 cents to 413.47 cents is our confidence interval. So let's go ahead and write up the interpretation of that. So with 90% confidence, the mean savings for a customer switching to this insurance is between 376, let's put my dollar sign in there, 376.53 to 413.47. Okay, so do these results agree with our hypothesis test, right? That's the next thing that they're going to want to ask, or want us to answer for them. So let's take a look. It says, do the results from the hypothesis test and the confidence interval agree? Explain. And say, yes, the value of 432 does not fall into our interval, and therefore would be deemed an unusual event. In other words, it would be very rare to see a value of savings of $432, given that our confidence interval, that we're 90% confident that the true population mean resides in that interval. Oh my gosh. Okay, well, hopefully that makes sense. This is another really good example to make sure that you get written up into your comp book in terms of the processes for doing a hypothesis test. In chapter 5, when we come back to chapter 5, we're going to start doing this all over again one more time. But the main difference between chapter 4 and chapter 5 is we're going to start looking at how to get the computer to do most of the work for us. And also really important is we're going to start looking at what do we do when the sample size is small and we're not so confident that we have a good estimate of the standard error. Okay, see you all back here soon.